Chapter 6.1 Exponential and Logarithm Function, and in this lesson we are going to discuss the exponential models. Exponential growth model is y equals a times 1 minus r to the power t, where a is initial amount, r percent increase as decimal, t is time, and the base, which is 1 plus r, is a growth factor. Exponential decay model, where y is equal to a 1 minus r to the power t, and similarly a is initial amount, r percent decrease as decimal, and t is the time. The base 1 minus r in this case is decay factor. Example number 2, solving a real life problem. The value of a car, y, in thousands of dollars can be approximated by the model y equals 25 times 0.85 to the power of t, where t is the number of years since the car was new. Letter A, tell whether the model represents exponential growth or exponential decay. So if you look at the base, that is 0.85, and I can see that this base is less than 1, so I would say that this is a decay, and I'm going to use the decay exponential function. So I'm going to use this a 1 minus r to the power t, because once I decided this is going to be a decay, then I'm going to use y equals a 1 minus r to the power t. Next thing is to identify the annual percent increase or decrease in the value of car. So if we decided that this is going to be a decay function, so it is obviously that we are going to find the percent decrease. Now we are going to compare this 1 minus r with the original function y equals a 0.85 t. So we can see that this 1 minus r is equal to 0.85. So when we compare that, 1 minus r equals 0.85. We're going to solve for r, so we're going to subtract 1 on both sides, and 0.85 minus 1 is going to be negative 0.15. Now we are going to solve for r, so it means that we are going to remove this negative. So to remove this negative, we are going to divide with negative 1 on both sides. So this negative cancel, this negative cancel. You're going to get r equals 0.15. So this r, which is a rate, it is in the form of decimal. But we want the answer in percent. If we need the answer in percent, means we are going to multiply this by 100 so that we can turn that into decimal. So this is going to be 15% decrease. So this is going to be 15% decrease in the value of car. Estimate when the value of the car will be 8,000. Graph on Desmos. So this is the graphing calculator you're going to use, and determine when y is 8. What is x? X means time in years. So when are you going to use the Desmos calculator? So you're going to use the Desmos calculator, and in the Desmos calculator you will type in this equation y equals, so you're gonna type in y equals 25 0.85 to the power x. So we're gonna treat this t as x because in the calculator it does not recognize the t, but you can use x. And you're going to look for, so you're going to look for x value when y is equal to 8. And when you find the point where x is approximately, when y is approximately 8, the intersection point would be this one. So the x value is about 7 years. Next, we're going to do the U-try problem number 5. In example 2, the value of car can be approximated by the model y equals 25 0.9 to the power t. Identify the annual percent decrease in the value of the car and estimate when the value of the car will be 8,000. We can relate this function as your decay function because 0.9 is less than 1. So this is going to be a decay function, and we're going to use the model y equals a 1 minus r, where 1 minus r is going to be 0.9. So 1 minus r equals 0.9. Subtract 1 on both sides, you get negative r equals negative 0.1. Divide with negative so that the negative and negative cancel, and you got r equals 0.1. When you multiply it by 100, you get the percentage, and we need the percent decrease. So the percent decrease is 10%. For this part right here, you can find out the value using the Desmos calculator. And when you use the Desmos calculator, you're going to find out the x value when the value of y is 8,000. So that intersection point is going to be almost 10.7 or 10.8 years.